So the last thing we're going to talk about is overloading. You may have noticed in your Python programming that the plus sign, if I use the plus sign and I have two strings on either side of it, what does that plus sign do? If you said that it concatenates the two strings together, you are absolutely right. But what happens if I have two numbers, two integers, or two floats on either side of it? What does that plus sign do? Yeah, it's going to add the two of them together because the plus sign has multiple things that it can do. Now, you've probably seen this in, let's say, for instance, a power function, a math.power function that can raise a base to an exponent. I could pass to it integers. I could pass to it floats. I might even be able to pass to it chars because chars have ASCII values, correct? And all I have is one function, power, or I think it's called pow. And the very fact that I have one function called pow that can do integers and floats and perhaps even chars is because that function is overloaded. My user doesn't have to know that I have multiple functions that are doing the exact same thing because they all have the same name. Now, the requirement is, in order to overload a function to have exactly the same name, there has to be something different about it so that the compiler or the interpreter will know which one of the overloaded functions to use. And what has to be different is the parameter list. So you either have to have a different number of parameters. Here's an example of an overloaded function, xyz. One has no parameters, one parameter, or two parameters. You either have to have a different number of parameters or the parameters have to have different data types. So the first one has two, an int and a double. The second one also has two, but now it's a char and a float. The third one has three. So in order to overload functions, which means giving them the exact same name, and here, this is an example here of 6 overloaded functions with the exact same name. All of them would run, and what is going to determine which one of these 6 overloaded functions will run is the arguments that your user is passing in the function call. So let's practice a little bit of function overloading. All right, so the last thing that we're going to do in this section is learn about overloading functions, and we found out that that just means having the same function or multiple functions with the exact same name. So how about if we write a function that will just print an array? So I have an array here, the same array that we were using when we were passing them to parameters, and this time I'm just going to create a function that uses a for loop to move through each one of the elements and print it. I'm actually going to put those below main again because this is my preferred place for function definitions. So I'm going to come down below main and I am going to create a function called print. It's void, doesn't return anything. I'm going to use a unsized function, which means, or excuse me, array, which means that I have to pass not only the array but the size. And then I'm just going to use a for loop to roll through it and printing each one of the elements and then a space after it. So I have this function called print. I'm going to take the function's header or the function prototype, also known as the function signature. I'm going to place it up here so that main will know about it. And then I am going to call it. So I'm going to call it. I'm going to pass to it 5 because I have 5 elements. And then I'm just going to force a couple of new lines because we're going to do some other overloaded functions. And so we'll just separate the output. So it should just be printing that. So how about if we move to a vector? We're going to come in here and create a vector and then write an overloaded function to print my vector. So this is the same vector that we were using when we were passing vectors to functions in the last video. So I'm going to come down here and I'm going to overload this print array or this print function to receive as a parameter a vector instead of an array. So on line 52 it'll have the exact same name. It is void and it is print, but this time I'm passing it a vector parameter. I do need to calculate the size of the vector, and then I'm just going to use a for loop to move through each one of the individual elements of the vector, and then I'm going to copy the function definition or the prototype up into the top above main, and then we'll come back here and we will call it by name. And we'll make sure to force a couple of new lines after that to get all of these runs a little bit separated. And so now I'm seeing the overloaded print function now printing not only my array but my vector as well. So how about if we try a struct as well? So I'm going to come up to the top. I'm going to declare my struct. This one is going to be called numbers. And then I'm going to go down there and I'm going to overload the function to print. So it's going to do the same thing. It's called print. I'm going to pass to it a structure parameter, and then I'm just going to print it out using our printf format. And then I'll come back into main and I will call it. Well, first of all, I'm going to have to set the values of a structure, declare a structure, and set some values, and then we'll. So I created a structure based upon my variable based upon my number struct. This is the same structure that we were working with last time. I did have to copy the method signature, the method prototype, up to the very top into our declarations. And then I should be able to call it by name, passing that struct parameter. And it should print out the same thing as well. So what we have is, we have so far three overloaded functions with the exact same name. We'll just add one more. Since we have a couple more minutes, we'll add one more. And how about an enumerator? So I'll copy the same enumerator we were using from the last video. I'll just put a couple of values in there. And then we're going to go down and we're going to overload the print function to print this enumerator. So I will return void. I will overload the print and pass to it an enumerator. And then I'm going to come up into main. I have my enumerator here, so I'm going to create a couple of enum variables, and then I'm going to call the function. So once I have pasted my function declaration up into the correct place so that main knows about it, I've come down here and I've created a enum variable called enum single. I'm going to pass that to the print statement, and we'll see if we can get back 5, which should give me the number 5. And there it is. All right, so now I have 4 overloads. I have one function that is overloaded, 3 overloads. Then, as I mentioned in the prior video, there has to be something different about all of these individual functions. They have the exact same name, print. The difference is either the number of parameters or the data types of the parameters that are being passed. It makes it very, very easy now to be able to create a function that the user just calls it by name, print, but then depending upon how they use it is which one of the overloaded functions will actually run. All right, it's your turn. We're going to practice putting all of this together. So you already have a smallest function that was accepting 3 values and returning the smallest, right? This time I want you to overload the smallest function, but this time I want you to pass to it an array of numbers. And now you're going to return to it the largest and the smallest number. And in order to be able to return those two, I don't want you to return an array, which, by the way, an array is not a return value in a C++, because arrays are automatically passed by reference, for that matter. So I want you to pass an array as well as a largest and a smallest value by reference, so that you can calculate, the overloaded smallest function is going to calculate the largest and the smallest, and is going to return those by reference in the 2 variables that you set. And as always, I want you to display all the relevant data in the return value, and then you're going to include comments or test cases for this one as well. And that will be practicing everything that we have done in functions.